Hi, this is Josh from Over the Shoulder Coding, and today we're going over Day 9 challenge. Day 9, we're working on Marble Mania. You talk to the elves while you wait for your navigation system to initialize. To pass the time, they introduce you to their favorite marble game. The elves play this game by taking turns arranging the marbles in a circle, according to very particular rules. The marbles are numbered starting with 0 and increasing by 1 until every marble has a number. First, the marble numbered 0 is placed in the circle. At this point, while it contains only a single marble, it is still a circle. The marble is both clockwise from itself and counterclockwise from itself. This marble is designated the current marble. Then, each elf takes a turn placing the lowest numbered remaining marble into the circle between the marbles that are 1 and 2 marbles clockwise of the current marble. When the circle is large enough, this means that there is only one marble between the marble that was just placed and the current marble. The marble that was just placed then becomes the current marble. However, if the marble that is about to be placed has a number which is a multiple of 23, something entirely different happens. First, the current player keeps the marble they would have placed, adding it to their score. In addition, the marble 7 marbles counterclockwise from the current marble is removed from the circle and also added to the current player's score. The marble located immediately clockwise of the marble that was removed becomes the new current marble. For example, suppose there are 9 players. After the marble with value 0 is placed in the middle, each player, shown in square brackets, takes a turn. The result of each of those turns would produce circles of marbles like this, where clockwise is to the right and the resulting current marble is in parentheses. The goal is to be the player with the highest score after the last marble is used up. Assuming the example above ends after the marble number 25, the winning score is 23 plus 9 equals 32 because player 5 kept marble 23 and removed marble 9 while no other player got any points in this very short example game. Here are a few more examples. And they want to know the winning elf score in our puzzle input. So let's take this example first with 9 players and using 25 marbles. So we know that we need to create a class called circle, or we can call it the game. We might need a class for the circle component of the game. We will want marbles as well, and we might want players. So what's interesting about marbles? Well, marbles have a left and a right, or a counterclockwise and a clockwise, and they're initialized with a value. Now, a circle in the game is also initialized with a starting marble. When the game is initialized with a marble of 0, the current marble is both clockwise and counterclockwise to itself. We also need a method for adding a marble. So when we add a marble, we're going to check the value of the marble. And we will initialize a marble with that value. Now, if the value is a multiple of 23, we will, for now, print else we will add it to between the marbles that are 1 and 2 marbles clockwise of the current marble. So we'll get the one that is 1 away. And we will set the new marble clockwise marble to be clockwise 2. And its counterclockwise marble to be clockwise 1. Marble that is 1 clockwise of the current marble. And then we will set the clockwise 1 marble to have its clockwise marble to be the new marble, and the clockwise 2 marbles counterclockwise marble to be the new marble. And so now the new marble is the current marble. So that solves the first part. We haven't implemented the second part yet if it's a multiple of 23. But what we can do right now is simply implement a print method. Right now, we don't really have a game or a player concept, but we're just going to test out our circle to see if it works. So let's see what the starting circle looks like. And then we're going to add first marble and print circle. So let's go for until we get to 23. We'll add I and we'll print the circle. So looks something similar, but not exactly similar because it's always starting at the current marble. So let's set it to be and let's start the print method at 0. So it looks similar, but not exactly the same. It looks actually reversed. So let's go in a clockwise method. See if we get something very, very similar. So it looks about right. We're able to iterate through the game. But we're not able to handle the 23 case right now. So what we want to do is when we add a marble, return 0 if the player doesn't get a score, or we're going to return the value of that new marble and the marble that is 7 marbles counterclockwise. So for I in range 7, the marble to remove is the marble that is 7 counterclockwise. Then we will get its value. We'll add it, and we will delete it. So we will say marble dot move dot clockwise. The marble clockwise equals what we're doing is the marble to remove clockwise marble, its pointer to its counterclockwise marble is going to be the marble that is counterclockwise to our current marble. And same for the other way around. So now the marble is no longer referenced in this circle. And we can turn the points. And we also have to set the new current marble. So the new current marble is the marble that was clockwise of the marble that was removed. So that should work. So let's do 24 and see what it looks like after 24. So when we get to this point, the new marble is a multiple of 23. So we don't add it. And we end up with this, where 19 is in removed 9. So we should have removed 9, but we didn't. So we didn't set this marble's value correctly. We removed the 5th marble instead of marble 9. So we didn't set this. Let's try it like that. So now we do remove marble 9. So we can play our game because we have a working circle. Oh, and we also want to check how many points is returned. So there should be 32 returned. Correct. So when we play this game, we need players. So let's initialize game with players. The players have a score. They have a number. So and players start at 1. So we will do self.players append player with a value of I plus 1. And self.circle equals circle. And we will play until we get till and last marble. So for I in range last marble, we're going to play each player. So we're going to start at 1, or we'll start at index 0 and increase the I by 1. So player equals self.players get I, so the player at the ith position, or I percent number of players. So if we start at I equals 0, we'll get the first player. Then what we need to do after that is score equals circle dot add marble, and then I plus 1. So we always start with the first value marble because we already put in the 0 marble. So player dot score plus equals score. And then we will print out the highest score. So def print I score, Bye. All the players. If player dot greater than the high score so far, high score equals player dot score, and the highest scoring player equals player. Then at the end, we will return high score. We'll print it as well. Print player and the player's number, maybe. One with a high score of high score. So let's try and play this game. So let's say game equals game with 5 players. Game dot play until we played until 25. Let's see what happens. So circle is not defined. Let's see where we have circle. So self dot circle. Then we print the high score. So we might also want to print the circle. Self dot circle. So the circle ends like this. With 25. So it doesn't add 25. So let's add in 25. So going until 25. We add it in. And we have player 3 won with a score of 35. Should have kept it. Oh, because we played a game with 5 players instead of 9 players. So let's play with 9 players and see what happens. So player 5 won with a high score of 32. So let's see what we get if we are doing 10 players and a game until 29. Let's maybe add a new Python file called test.py. And we can let's look up some docs on how to set up Python unit tests. Let's do def example. It was the example. Game with 9 players, and they played until 25. and we want the high score. And we also want the player, but we just want the high score right now. So assert high score equals 32. Let's put it in here, see if that works better. Let's see if it fails, if it's 31. Doesn't really work. I'm going to skip this for now. And we're just going to do this. And test it out with a few other test cases. So 10 players. Play until 1618. And a high score of 8317. So what about 13 players and 146373 or 799? Okay, looks good. So let's try the puzzle input. 418 players and 70,000 some odd marbles. So player 137 won with a high score of 400,000. So let's submit it. And that's the right answer. So we got our first gold star. So give me a thumbs up for that first gold star. Part two, amused by the speed of your answer, the elves are curious. What would the new winning elf score be if the number of the last marble were 100 times larger? So let's go change our game rules and say if I equals last marble times 100. So let's try that. So it seems still the same, but let's see, 70769 over 23 doesn't divide evenly. So they're not going to get the last score. So this could be correct. Oh, so it wasn't the right answer. 70769. over 23. Doesn't divide evenly. So let's look for that last marble. Let's see if we can find it. So 70769. We multiplied it by 100 and still added 1. So that's not what we wanted. So we're just going to stop this early and add this one more time manually. So got it. So could have worked maybe if we had done I here. Then we offset it by 1 here. So if I equals last marble, then we will multiply by 100 and subtract 1 because we add 1 anyways to I. So that'll offset that. So let's look for that last marble. 70769. 70769, 70769, 100. So it seems like the winning elf score would be the same if the number of the last marble were 100 times larger. Well, we got the same answer and it was too low, but it doesn't seem like the marble is being taken out. Unless they meant the largest marble taken out. So we could do that. So we could say whenever a player scores, we will store the last marble. Then when we exit this, we will subtract the last marble scored, and then add 100 times its value. So seems like this player So let's print out all the player scores. At this point, player 128 has a score of 316115. So the marble 7071 or 7771 is worth 23. But it's really not the marble we are searching for. Oh, they want us to play the game out 100 times larger. I think. So let's try that. So this is probably testing the runtime of this. So let's look at the runtime of our game. So for each step in the game, we're adding a marble. And when we add a marble, it's constant time for the new marble and only 7 for the marble that's a multiple of 23, which is still constant time. So I think that was the question. All right, so that's the right answer. And we got our second gold star for the day. If you like this video, please give it a thumbs up and support me on Patreon so I can find time to make more videos. And as always, subscribe so you can find out when I post the next video. Thanks, and I'll see you next time.